Hi, and welcome back to another one of my IHSDM Open Roads tutorials. Today we're going to be going over a couple of different things, but this first video is going to be mainly just on the data input of IHSDM, just the basic data inputs for various alignments. Other topics I'm going to cover in the rest of the series is entering traffic data and projections. I'm going to be going over how to model ramp connections, ramp terminals, intersections, and arterial streets. And the last topic will be running basic evaluations for results. So just to get started here and set the stage a little bit, I've got a stretch of a highway out in Colorado. It's about a quarter of a mile, maybe a little less, of a 6-lane freeway facility. I've got one crossroad, which isn't very big, and then I've got two ramps. I've got one off ramp, one on ramp, and then we'll be modeling two ramp terminals later in the video. So I've already done the hard part of creating all these alignments and exporting them into XML format, which can be read directly into IHSDM. But just to go to show, I did label all the stationing in Open Roads, so all the alignments have an associated station already. So let's hop over to IHSDM. So this is what the general IHSDM interface looks like. This is another project I'm working on concurrently. This is kind of what the editor will look like. So in our case, we're going to want to create a new project because I have not worked on this yet. I'm going to title it I-70 Safety Evaluation. Units, we always use US customary metric. Don't even bother about it. You can type in a description of the project if you want, but it's not really that useful if you're the only person working on it. Okay, so the first step is we want to get all four of these alignments into Open Roads, or into IHSDM, and then we'll work on kind of connecting them together in future lessons. But I want to get them imported, and I want to enter basic data such as number of lanes, median width, shoulder width, things like that. So we're going to go back into Open Road or IHSDM, and then we're going to use this import highway intersection set. And then you're going to scroll to where you have your alignments saved. So here are my four alignments. I've got the main line, I've got the off ramp, I've got the on ramp, and then the crossroad alignment. So I'm going to go ahead and import this mainline alignment. Typically, you want to do your mainline alignment first because it will show up first in the list underneath the project. And you'll see what I mean once we start getting a couple more of them in here. Alright, so it was very easy to import it. Just note, if we click on view, nothing's going to show up because we haven't entered any data yet, but the view highway is a very powerful tool in this program. So let's just go into the alignment I-70. So this is where edit highways, where you enter all of your information. So this is the all data screen. This kind of just shows basic information that's in here. It shows the stationing that you defined in open roads, your geographical coordinates. I did this in using a coordinate system. It will also show your horizontal and vertical components. So I've got all my horizontal geometry in here. I've also got my vertical geometry, and I just did it as a flat road. However, this is a very steep section in practice, which has, I think, like a 6% downgrade. So if if I wanted to, I could change this forward grade to a negative 6% to get kind of a more accurate vertical profile. But for the sake of this, I'm not going to. I'm not entirely sure how much the vertical profile affects the results. It's something that we haven't really had a chance to manipulate with yet, and also it's a lot of additional work. So these two are auto-populated once you complete your Open Roads modeling. So the general tab, these are three classes you will have to fill out. This average annual daily traffic is going to be a separate short video, but area type and functional class we can fill out now. So the area type, it gives you rural, suburban, or urban. This is kind of in a suburban area. Urban would be like a downtown of a dense city. So if it was a freeway surrounding downtown Dallas or downtown Denver or Milwaukee, you would pick urban. Suburban is kind of in between rural and urban where there's not really a ton around it. And then rural is just like out in the country. You're modeling like a 2-lane rural facility. I know I said suburban. I'm gonna put urban just for the sake of this video and the modeling effort. Um, and if you have an alignment, you can also do specific station ranges if you want multiple area types on one alignment. So functional class is like what kind of roadway it is. So there's arterial, collector, local, freeway, freeway service ramp, and freeway CD ramp. These are pretty important to make sure that you model correctly. The ones that we primarily use are these freeway ones. I don't generally like to model arterials, but sometimes we have to, and sometimes we also have to model local roads. But the results for them really aren't ever that great. But for this section, we're going to just go ahead and call it a freeway because that's what it is. So our general classification is an urban freeway for this alignment, which if we go back into our open roads, is pretty much what it is. So it's a high-speed facility, 6 lanes. So the next important data that we can enter is the number of lanes, ramp connections, which we're going to talk about in a future video, lane offset and two-way left turn lanes. We typically don't use these. Lane offset is more of a visual component, which our model reviews aren't very stringent with WSDOT or any of our clients, so I typically tend to just ignore those because they take a lot of time and really aren't worth it. And then cross slope is just your cross slope of the road. I tend to just leave these at 2% and then don't bother with them. But once we start getting fancier, there might be a way that we can input super elevation data into these cross slopes. But for now, I'm not too worried about it, and it doesn't have that big of an impact on the results. So I'm going to go ahead here and just show what happens when we put in 2 lanes worth of data. So the best way to explain this is when you're picking the side of the road, the right side is going to be, if we go back into our open roads, the right side is going to be on the right side counting upwards in stations, and the left side is going to be on the left going upwards. So if I specified 1 lane on the right side, it's going to show up on the right side of this alignment. If I pick left, it's going to be on the left. And then if I pick both, it will appear on both. So because I said this was a 6-lane facility, you would think you would do 3 lanes on both sides. And that's typically a pretty good assumption, but if you look kind of towards the end of our model, we get down to 2 lanes on the right side and 3 lanes on the left side. So just for this basic data, I'm actually just only going to input 2 lanes on the right-hand side and 3 lanes on the left-hand side. Another key concept of this is priority of the lanes. So this kind of just shows how they're displayed. So I'll enter in the data, and then we can talk about the priority rules. So the priority rules just kind of mean like where it shows in relation to the alignment. So for this right hand side, I've got 2 lanes, one with priority 10, one with priority 20. So I'm going to go ahead and hit file update here. I'm going to exit out. Now I'm going to go back into our highway viewer. Sometimes this is kind of wonky where you have to close your program and reopen it if you start a new project. So you might have to deal with that a little bit. So I'm going to come in here. I got my I-70 main line. You can edit it still. And now there's also this view option. So now you can view the highway or the freeway that you just created in this alignment editor. So you can see here's our yellow line, which is the roadway center line that we designed in Open Roads. On the right side we have 2 lanes, on the left side we have 3 lanes. Back to the priority rules, the priority 10 is going to be closest to the center line, so this lane is priority 10 on the right, this lane is priority 20 on the right, and then same thing for the left. The inside is 10, 20, 30, and you can build out as far as you want for priority. I typically go in increments of either 5 or 10, 10 for lanes, and then 5 for shoulders. But I'll show you the shoulder editing separately here. So this video is getting to be a little lengthy, it appears, 10 minutes. I'll plow through this one. Might be kind of a long tutorial compared to the others. This is kind of the crucial one. So now that we have some basic lane data in here, I'm going to go back into the edit tab and show you, now that we set the general area and functional class, we had a lot of other options also appear. So it thinks it's a rural 2-lane. Maybe I should have done it as a well, anyways, what we're really worried about here is the freeway segment data and also this road cross section. So now that we've updated it, you can see we have this shoulder section that popped up, and we also have our cross slope, which I said I'm just going to leave as 2%. I'm not even going to fill it out for the purpose of this. But we have our shoulder section. So for simplicity's sake, I'm going to just say that we have a constant shoulder width the whole way. So our priority is going to be 5 because it appears, sorry, this is an inside shoulder. I'm going to say the priority is 5 because it will appear on the inside of the 2 lanes. So as far as getting a width for it, I'm going to look into our Open Roads file here. That looks to me, maybe a 3 or 4 foot inside shoulder. It's a little hard to tell from this aerial. I'm just going to say it's 4. So you enter in your width, and then you can change the material if you have a paved, gravel, or different material. It doesn't generally, paved versus gravel doesn't matter, but you can enter either way. So this will set the inside shoulders, but now you also have to set outsides for both the right and the left side. If we go back into Open Roads, it looks like it's potentially a 12-foot shoulder on both sides. So let's go back into our modeler here. So we're going to set our left one first, again with a 2% typical slope. We're going to set a 12-foot width with a priority of 40 because it's on the far outside of that left lane, and our last lane is priority 30. So I'm going to just copy this over for the right-hand side for an outside shoulder, but the priority for now, we'll have to edit it eventually. I'm going to change it down to 30 because there's only 2 lanes there right now. So if we do file update again, we exit off and we view the highway. Now we have 3 lanes, and then 2 lanes, and then your shoulder, and then also your inside shoulders. The last thing I want to point out here is there's other data that you can enter in here. Now that you can see, we're going to be talking about this later. Okay, I guess the other ones that I want to specify that we typically input is the median, and then also the median barrier and outside barrier. So as far as a median on this project, it's not entirely apparent. Okay, yep, I guess actually there is a median. So 36 feet, I'm gonna say it's a 40-foot median. up until about station 231. So I'm going to go back into open road or IHSDM. I'm going to enter 231 plus 00. So this is what we just determined. So it starts at 200 and goes to 231. It's a non-traversable because you can't drive across it. It's protected by a barrier. I'm going to say the width is 40 feet or so. Now we also need a section of median where we taper down from 40 feet to 0 feet. So if we go back and look in open roads, it looks like it tapers down to 0 feet, I'd say at about 242. So we have a non-traversable median with a starting width of 40 and then it ends at 0. So now if we update it again, oh, we got an error on that on that update. Right inside shoulder not completely contagious with the median. Okay, that's fine for now. So if we view our highway again, now you can see we had our median, 40-foot median show up. So if you find station 231, which appears to be marked right here, now you can see the taper down from a 40-foot median back down to a 0-foot median. So that's how you enter a median. They're always non-traversable. Typically for freeways, you'll never enter a traversable median. Probably not even on rural facilities. But that's how you enter median data. And the other two things I want to highlight here is outside barrier and median barrier, both of which are typically present along the whole facility of an urban freeway like this. And barrier is just kind of, the IHSDM roadside crash barrier or concrete median barrier. Just if your car goes off the road, it crashes into it, and you don't run off the road. But we can model that in this. So we go back to our edit highway. Here's our median barrier. Remember, we have a 4-foot shoulder, so I'm going to say it's the whole length of it. So the barrier is going to be 1 foot past your shoulder width. So our shoulders were 5 feet. So I'm going to say the offset of the barrier is 5 feet. So it's a foot past the 4-foot shoulder. So I'm going to go ahead and add that in. So that will be a concrete median barrier, the whole length of the project. As far as outside barrier, for now I'm only going to set the left side because the right side is still going to need some lane adjustments. So our left side barrier, we have a 12-foot median. Outside barrier, you want to be 2 feet past your outside median. So I'm going to say the outside, I should also say this is from the outside of the traveled way. So if we look back at our editor in a second, you'll see what I'm talking about. But you want it to be 2 feet past your shoulder width. So you're setting it from the traveled way line. So your outside shoulder is going to be based off the outside of the traveled way, and your inside barrier is going to be based off the inside of the the inside traveled way. So now for this mainline alignment, we pretty much have all the information in here that we want. Some of these other ones, just so we can talk about them quick. High volume sections, you can generate them automatically once we put in AADT value. Weaving sections we typically don't use because IHSDM can't analyze them very well. Clear zone, we typically don't use it for facilities that have barrier the whole way. You might use it for like a rural 2-lane highway. It's really not that powerful of a parameter. User-defined CMF sometimes we'll enter if there's something we want to model that can't be captured directly through the modeling. Like if we're applying a high friction surface treatment, we would enter a specific CMF here. And then if you're doing an empirical Bayes analysis where you get historical crash data, you can enter all that information directly into this. We typically don't do these. I've only done 2 or 3 of them in my time here. But once if you ever need to do it, it's pretty straightforward. So in hopes of not making this session too long, I'm going to cut it right here. We've still got 3 more alignments to go. so we've got 3 more alignments to go, and I'm going to go over them in the next video, and then I'm also going to go over editing the rest of this right. So the left side is good. I'm going to go over editing the rest of this left side of, sorry, the right side of this freeway alignment.